Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 21. Some facts about graphs of linear equations in two variables. Okay, so the classwork example number 1 says, let a line L be given in the coordinate plane. So there's line L on the coordinate plane. What linear equation is the graph of line L? So they want us to find a linear equation, which is y equals mx plus b, where m equals slope and b equals y intercept. So usually what we do with a linear equation is look for the y-intercept first, and if it's an integer, fantastic, we just plug that in for b. But in this situation here, it is between 2 and 3. We cannot assume that's 2.5. It might be 2.6, 2.7, something like that. Some fraction other than 1/2, in other words. So, in order to find the slope of a line, we need 2 points. And if I look here, there is a point right here on this corner, so that is an integer. That is the point. X is 5, comma, y is 4. So there's 1 point we have. That is not an integer. Neither is this or this or this, and I keep going until I find one that is, and here is another one that is on a corner of the grid, which makes it an integer x and y, and that would be x is -2 and y is +2. So there's my 2 points, -2, 2, and 5, 4. Okay, there's two different ways we can do this. I will do both. I can just simply state how high do I have to go, how many units up do I have to go before I'm on the same height as this, and that's a distance of 2. And then how far to the right do I have to go? 3, 4, 5, 6, 7, and this is a length of 7. Okay, so my slope is up 2 over 7. So now my equation is y equals 2 over 7x plus b. Okay, so now I found my slope. Now I'm going to show you, and before I continue though, I want to show you a different way to find the slope. Slope equals the y value of your second point minus the y value of your first point, or we can say the difference in y over the difference in x, which means the x value of your second point minus the y value of your x value of your first point. Okay, so it's y2 minus y1 over x2 minus x1. So if I labeled this x1, y1, this is my first point reading left to right, and this is my x value of 0.2, and this is my y value of 0.2, and if we label it up like that, we can find our slope this way. So what's y2? y2 is 4. Minus, what is y1? Well, y1 is right here, it's 2, over x2, which is 5, minus x1, which is -2. Be careful with a minus and negative. So 4 minus 2 is 2, and 5 minus a -2 is 5 plus 2, which equals 7. And as you can see, we got that from the graph just going up 2 over 7. So these are the two ways you can find the slope of a line. But now we have to focus on our b. Well, in order to find our b, we have to use one of these points and plug it in and solve for b. So I don't want to use a negative if I don't have to. So I'm going to use the 5, 4. So my y is 4 equals 2 over 7 times my x from that point, which is 5. Okay, let me put that in parentheses like this, plus b. Okay, so there's a couple different ways we can do this. This is 10/7, but if I want to get rid of that 7, I can multiply everything by 7. 7 times 4 is 28. These 7s cancel, and I get 10, because 5 times 2 is 10/7, and then the 7s cancel, plus 7 times b is 7b. So all I'm doing is the distributive property here to get this value. So I'm kind of skipping a step there, so that might be confusing to you. So let me fix that a little bit. Just give me a moment here. So here we are. Let me fix this. So I have plus b. So let's multiply this first. 4 equals 10 over 7 plus b. Okay, so now I want to get rid of that 7. Now I multiply by 7. 7 times 4 is 28. 7 times 10 sevenths is 10 plus b. If I subtract 10 from both sides, then I get 18 equals b. Okay, and that doesn't make any sense because it is between 2 and 3. For some reason, this is not working. Okay, and of course, the reason is I forgot to distribute here. That is 7b. So it's 7b equals 18. Okay, so 7 times 4, 28. 7 times 10 sevenths is 10. 7 times b is 7b. Subtract 10 from both sides, 18 equals 7b. Divide by 7, and now life is good. 7 times 2 is 14 with a remainder of 4. So as you can see, my b is 2 and 4 sevenths. So 2 and 4 sevenths. It's not 2 and a half. See, we can't just assume that. So now I finally rewrite my equation, which is this form right here, with an m and a b that we've found. So my answer is going to be y equals 2 sevenths x plus 2 and 4 sevenths, or I would leave it 18 over 7. So that is the equation of example 1. Now let me take this one step further and put that in standard form. So let me just erase the bottom of this box here, and I'm going to continue. And let's get this in standard form. In other words, I have to move this 2x over to the other side like we did in previous lesson by subtracting 2 sevenths x from both sides. Okay, so if I subtract 2 sevenths x from nothing, I get negative 2 over 7x equals, or plus y, I mean, 2 over 7 x plus y equals 18 over 7. Okay, again, a cannot be negative and a cannot be, none of them can be fractions, so now I need to multiply everything by a negative 7. So this is going to cancel the 7's, and the negative times the negative is positive 2x. Negative 7 times y is negative 7y, and then I'm going to get a negative 18 when I multiply negative 7 times 18 over 7. So this is my standard form, and this was my slope-intercept form. Same equation. Okay, number 2. Let L be a given coordinate, a line on the given coordinate plane. What linear equation is the graph of line L? Again, we have a b that is not an integer. We cannot assume that that is 1/2. So I write the equation y equals mx plus b. I want to find m first. M equals y2 minus y1 divided by x2 minus x1. So my slope is going to be, find a point that's an integer right here, and then I move down until I find the next corner, which is right here. So this is the point negative 1, 4, and this is the point 4 comma positive 1. Now, just until you get the hang of this, label this. This is my first point, so I'm going to call that x from my first point, y from my first point, x from my second point, y from my second point. That's what those subscript mean. So I want my y from my second point, which is 1, minus my y from my first point, which was 4. So it's 1 minus 4 divided by x from my second point is 4. X from my first point is minus a negative 1, so be careful with that. 1 minus 4 is negative 3. 4 minus a negative 1 is 4 plus 1, which is 5. So my slope is negative 3/5. Now I'm going to substitute in one of these points and this to find my b. So I have a y, which is 1. I have an m, which is negative 3/5. And I have a b, which is 4. Or an x, I mean. All I need to find is b. So once I get an equation where I only have one unknown, we can find it. So I'm going to simplify this. So that's negative 3 times 4 is negative 12 over 5 plus b. Okay, there's two different ways I can do this. I did the last one by multiplying everything through. I'm going to do this one differently. Let you decide which way you prefer. If I'm going to add and subtract fractions because I need to move this away from b, I'm going to be adding 12/5. Then I need a denominator that's the same. So I need to have a denominator of 5 over here. And what is equal to 1 other than 5 over 5? So if I add 12 over 5 to both sides, then I get 5/5 plus 12/5 is 17/5 equals, these cancel, b. Actually, this way is easier. So if you can convert your integer to a fraction with the same denominator, it's easier than multiplying through by everything and getting larger values. So there's my b, and now I can write my equation. So I'm going to bring this down here and write it as y equals m negative 3/5 times x plus my b, which is 17 over 5. So there's the equation in slope-intercept form. Now I need to take that and make it standard. So I rewrite it. I want to move this over here so it's first. So I'm going to add 3/5 x to both sides. So I have 3 over 5 x plus y equals 0 plus 17/5. I don't want fractions in my standard form, so I multiply by 5. These cancel and I get 3x plus 5 times y is 5y, and the 5 times the 17/5, the denominator and the 5 cancel, leaving me with 17. So this is my standard form. This is my slope-intercept form. Okay, example 3 says, let a line L be given in the coordinate plane. Write a linear equation that is the graph of line L. Okay, so here's example 3. I always look at the y-intercept first, and when I see that it is an integer, I breathe a sigh of relief. It's less work. No kidding, but anyway, it is easier. Y equals mx plus b. Okay, or ax plus by equals c. Slope-intercept form, standard form. We're going to do both. Here they gave us the b. They gave us our y-intercept, which is 12. Actually, that is not the y-intercept, so I take that back. Now I'm looking at the grid here. I thought this line was thicker, and I thought that was my y-axis. We are way over. This is the x-axis at 12 up 2. So they're only showing a portion of the grid. We don't even see the y-intercept in this problem. So there's no way of even estimating it. It is way down here off the screen. But I do know that my 12 comma 2, do I assume that? I don't see a y-axis anywhere with any value on it. Okay, I just wanted to confirm this. I really do not like the graph that they offered us here. They are only showing a snapshot of a portion of the x-axis, and they aren't showing the y-axis. And yes, the x value is 12, and I am kind of making an assumption, thinking that this is 2, because we don't have a y-axis over here that is labeled with numbers with a unit of measurement. This could be 2, 4, 6, 8, but if we assume that these are unit squares, then this is 12 comma 2. So let's go with that. So if we have the point 12 comma 2, we need to find another point on the grid that is an integer, and that is right here. And this is the point, change colors here. This is the point 13 comma 3, 4, 5, 6, 7. This is the point 13, 7. Okay, now I'm going to think back, and I'm going to make this a little bit easier than doing y2 minus y1 over x2 minus x1 to find my slope. And a couple of lessons back, I don't remember the lesson, 15, somewhere around there, they said that if we had 1 unit measure movement to the right, then our rise over 1 is just our rise. So our slope is the number we went up. So we went from 12 to 13, which is a difference of 1. And we went from 2 to 7, which is an increase of 5. So now I know my b. So y equals 5x plus b. Okay, so I have 5x plus by equals c. So I found my m, my slope, is 5. But I don't want to jump the gun here because this might not be what it comes out to be, so don't do that yet. Okay, so we're going to finish this slope-intercept form first. So y equals 5x plus b. I have an x and a y. I can use either one. It doesn't matter. I always prefer the smaller ones as long as they're not negative, if they're both positive. And my x is 12 and my y is 2. So I'm going to put those in my equation. So 2 equals 60 plus b. And when I subtract 60 from both sides to get b by itself, I get negative 58 equals b. Okay, so I'm going to come down here, and I'm going to write y equals 5x minus 58. There is my slope-intercept form of my equation. Okay. Now I need to convert this to slope-intercept form. So I couldn't just plug that 5 in there because look what's happening. I need this 5x here, and it's over with the c right now. So I need to take y equals 5x minus 58 and move this over here because this is my a and it's not in the right location. I'm going to subtract 5x from both sides. And I get negative 5x plus y equals negative 58. Do not forget this negative sign. And I can't have a negative, so I multiply everything by negative 1. So I get 5x minus y equals 58. And there is my standard form. Okay, example 4. A line going through the origin. Isn't that a beautiful thing? Y equals mx plus b. Well, guess what? My b is 0, so all I have is the equation y equals mx plus 0, or simply mx. When I find my next integer, I had to go, I'm just going to do it this way this time, up 1 and right 3. So my slope is rise 1 over 3x. Okay. What linear equation is the graph of this line? Y equals 1/3 x. That's slope-intercept form. Now I want ax plus by equals c. So if I solve this and put it in the right order, then I'm going to take y equals 1/3 x, and I want x over here. See, it's over with the c here, and now I got to move it first. So I'm going to subtract 1/3 x to get it over with the y. So I have negative 1/3 x plus y equals 0. Don't forget that 0. 1/3 x minus 1/3 x is 0. I don't want a to be negative or a fraction, so I'm going to multiply by a negative denominator. 3. Negative times negative is positive. 3 times 1/3 is 1x. Negative 3 times y is negative 3y. And negative 3 times 0 is still 0. So this is my standard form, and this is my slope-intercept form of the same line. Okay, now it's exercises time. Your turn to try this. So pause the video. Okay, sorry for that. So we're going to write an equation for this. Hopefully you've tried it, so here we go. First thing I always look at is my y-intercept. It is not an integer, so I'm going to write y equals mx plus b. I need to find integer values, and there is a corner here, and there is a corner here. And to get there, I have to rise 1 and run 3. So my slope is y equals 1/3 x plus b. So we've got our slope now. And then we have our points. So we have the point negative 1 comma negative 3. And we have the point 2 comma negative 2. Doesn't really matter which point you use. I will just use the 2 negative 2 just because. So my y is negative 2 equals 1/3 times my x, which is 2, plus b. So I have negative 2 equals 2/3 plus b. And I'm going to erase that negative 2 because I should be aware that this is a fraction and I need a denominator of 3. Well, what is negative 2 times 3 is 6, so negative 6 over 3 is negative 2. Now I'm going to subtract 2/3 from both sides. And when I do that, I get negative 6 minus 2, which is negative 8 over 3 equals b. So finally, I can take my equation and write y equals 1/3 x minus 8/3. Putting this in standard form, y equals 1/3 x minus 8/3. I'm going to move my 1/3 x, and I'm going to get negative 1 over 3x plus y equals 0 minus 8/3. Okay, standard form does not allow us to have a fraction or a negative a, so I'm going to multiply by a negative 3. So negative 3 times a negative 1/3 is x, or 1x. Negative 3 times y is negative 3y. And negative times a negative is positive. The 3's cancel, and I get x minus 3y equals 8. So here's slope-intercept form, and here's standard form. Number 2, write the equation for the line L shown in the figure. Okay, first thing I look at, y-intercept is not an integer, so I'm looking for integer values. There's one, and here's one, and I could also have used this one. So it doesn't matter which one you use. I prefer positive, so I'll work with this over here. So this is the point 2,8, and this is the point negative 3,7. So either way, it doesn't matter. And this is the point negative 8,6. Okay, so I'm going to find the slope this way. Since it's a graph, it's much easier to do it this way. This is a rise of 1 and a run of 1, 2, 3, 4, 5. 5. Difference in x is 5. Difference in y's is 1. So I have the slope up 1 over 5. So my slope is, my equation is y equals mx plus b. My slope is rise over run. So my slope is y equals 1/5 x plus b. Okay. And that's a 5. Let me fix that. It doesn't look right. So 1/5 x plus b. Okay, so now I'm going to plug in any one of these, and again, I prefer positive, so I'm going to stick with this 2,8. So y is 8. 1/5 times 2 plus b. Okay, I have a denominator of 5, so I'm going to change 8 to 40 over 5. And I'm going to get 2 times 1/5, which is 2/5, plus b. I'm going to subtract 2/5 from both sides. And I get 38 over 5 equals b. Now I write my equation with everything in it. I have my slope of 1/5 and my y-intercept of 38/5. Again, this is a 5. Okay, rewrite that here. Y equals 1 over 5x plus 38 over 5. I'm going to move the x over here, so I subtract 1/5 x. Okay, so a little distraction there. The PA is busy today. Okay, so I'm going to subtract 1/5 x from both sides. I get negative 1/5 x plus y equals 38/5. Okay, these cancel. I get 38 over 5. I don't want a fraction or a negative a in my standard form. So I'm going to multiply by negative 5. So when I do that, negative 5 times negative 1/5 is 1x, or just x. Negative 5 times y is negative 5y. Negative times a positive is negative. The 5's cancel, and I get 38. Okay, I keep showing these steps over and over and over, but there is a formula that we learned earlier, but I will keep doing this rather than trying to memorize a formula. Learn how to convert from slope-intercept to standard form. Okay, number 3. Now that says determine the equation of a line that goes through these 2 points. Now they're not giving us a graph, so I can't use the rise over run thing, so I have to start off with, I need an equation, y equals mx plus b. That I do know. but I need to find m, and m is y2 minus y1 divided by x2 minus x1. This is x1, this is y from 1, this is x from 2, and this is the y from 2. So I'm going to plug those values in. y2 is 3 minus y1, 5, divided by x from 2 is 2. Okay, all kinds of music today. So 3 minus 5, and then finally, where was I? X2 is 2 minus x1, careful with the minus a negative 4. So 3 minus 5 is negative 2, and 2 minus a negative 4 is 2 plus 4, which is 6, and that reduces to negative 1/3. So there is my m. So now I have y equals negative 1/3 x plus b. Okay, I'm going to use this because there's no negatives. Y is 3 equals negative 1/3. X is 2 plus b. So I'm going to get negative 2/3 plus b here. And I need to subtract. So I need a denominator of 3 over here. So I'm going to change 3 to 9/3. When I add 2/3 to both sides, now I can do the addition of the fraction. 9/3 plus 2/3 is 11/3, and that is my b. So my equation now is y equals m x plus b. Rewrite that. Y equals negative 1/3 x plus b, 11/3. Move this over to put it in standard form by adding 1/3 x to both sides. And when I do that, I get 1/3 x plus y equals 11/3. I can't have a fraction or any fraction, so I multiply by 3, and I get x plus 3y equals 11. As you can see, I'm speeding up a little bit here. You should be comfortable with the distributive property. Number 4. Okay, so again, we're going to write the equation for the line L shown in the figure. And we do not know where it's crossing the y-axis. It's way down here somewhere, so I don't know what b is. Okay, but I do have an integer point right here, and we do have an integer point right here. This is the point negative 7, 2. And this is the point negative 6, negative 2. Okay, so since it's on a graph, let's just do the rise over run. That is a distance of 4 in the downward direction. And then I go to the right 1. So if we only move 1 unit to the right or left, negative 7 and negative 6 is a distance of 1. Your slope is your rise over 1, which is just your rise. So we have y equals mx plus b. And my m is negative 4. So y equals negative 4x plus b. Now I use one of these 2 points. It doesn't matter. I prefer less negatives, less chance of making a mistake with a sign. I will use the negative 7, 2. This will be my x. This will be my y. So 2 equals negative 4 times that y, which is negative 7 plus b. 2 equals negative times a negative is positive. 4 times 7 is 28. Subtract 28 from both sides. Okay, and 2 minus 28 is a negative 26, and that is my b. So if I went down to negative 26, that's how far down we have to go before this line is going to reach the y-axis. Now I'm going to write my equation, y equals, with my slope, negative 4x, and my b, negative 26. Y equals negative 4x minus 26. I have to add 4x over to this side to put it in standard form. I get 4x plus y equals negative 26. A is positive. There are no fractions. This is standard form. This is slope-intercept form. Okay, number 5. A line goes through this point and has a slope of this m. Write an equation that represents the line. So if I write the equation y equals mx plus b, and I plug in all my values they gave me, this is x, this is y, and this is m, then y is 3, m is 4, x is 8, and the only thing I don't know is b, which is the y-intercept. So 3 equals 4 times 8, which is 32, plus b. Subtract 32 on both sides, and 3 minus 32 is a negative 29, equals b. So therefore, my equation is going to be y equals mx plus a negative 29 or minus 29. So there's the equation of the line in slope-intercept form. And I'm done it every other time. I'm going to do this again. Practice, practice, practice. Rearranging equations. Subtract 4x. Okay, subtract 4x from both sides. And I get negative 4x plus y equals negative 29. I can't have a negative, so I'm going to multiply by negative 1. And I get negative times negative is positive 4x. Negative 1 times y is minus y. And a negative times negative is positive 29. So this is my standard form. Okay, that is the end of lesson 21. Review the lesson summary and go to your problem set.